So quadratic formula day 3, we're just going to work through a few of our examples, simplifying our non-perfect square roots. We'll do a few of those basic examples at the end as well. So we'll start off with this one. In order to use the quadratic formula, the quadratic itself has to be in standard form, and it has to be equal to 0. So right now it's not in standard form, and it's not equal to 0, so the first thing we're going to do is add 9 to both sides. There's the 0 that we are looking for. Now that it is in this form like this, we're going to use our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, another technique we could use to solve quadratics, we can graph, you can try to factor, we can use the formula, and then the one we haven't learned yet is complete the square. Why I told you guys in class that quadratic formula, you guys are going to kind of hate me a little bit, is the formula works on every single quadratic as long as it's in standard form. Graphing also always works, but we know that's kind of a pain in the butt. Factoring doesn't always work. And completing the square is actually it's a little bit of a time-consuming method. So get very familiar with the quadratic formula. We're going to use it when we get to our word problems later on. Now that we have our quadratic formula, we're going to put all the pieces together. Remember, A, B, and C. Just like we learned yesterday, we're going to check our discriminant before we get started. So the stuff that is underneath our square root symbol. So that gives us negative 12 squared minus 4 times 9. So that gives us 144. I'm not 100% sure what all these other numbers are. So we're just going to multiply 4 times 9. It's also 144. That's kind of cool. Negative times positive, so it's still a negative. We end up getting 0 underneath, which means this quadratic has a double root. Put all the pieces into our quadratic formula. We get negative 12. I'll come back and simplify that in a second. Underneath, we already know that it's 0. And then we have 2 times 4. Again, I know I could simplify it as I write it out, but I don't want to make any silly mistakes. Or if I do end up making a mistake, I want to be able to find it. So 2 times 4 is 8. The negative 12 becomes positive, and the square root of 0 is 0. Meaning our answer is 12 over 8, which we simplify. 4 goes into both of them. 3 halves. It is a double root. Both of the answers are 3 over 2. Maybe we got this one. We want to get it into standard form. It doesn't matter if the 0's on the right side, so we could subtract 2x squared to both sides and get it into form. I will say that I always want my leading coefficient to be positive, so I'm actually going to subtract 3x and add 3 to both sides, giving me the 0 on the left, 2x squared minus 3x plus 3. All of that just so I can have the first number to be positive. It's easier to factor, it's easier to use complete the square, it's easier to use quadratic formula. I just like having the leading coefficient be positive. Does it matter? No. It's just easier. Now that we have it in standard form equal to 0, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, let's check our discriminant. we end up getting negative 3 squared minus 4 times 2 times 3. It gives us 9. 2 and 3 is 6. Times 4 is 24. Minus 24. Ends up giving us a negative 15. Since it's negative, this is no real roots. We don't have to do anything with this problem. The answer's already here. Alright, say it's already kind of in standard form, but it says y equals. We get to set it equal to whatever we want. So we're going to set it equal to 0. So we're ready to go. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Check our discriminant. So we get negative 4 squared minus 4 times 4 times negative 3. We get 16. Negative 4 and 4 is negative 16. Negative 16 and negative 3 is a positive 48. Add those together and I do believe we get, that's 64. I want to make sure my math is all right here. 4 times 4 times 3. 48, I thought so. Plus 16 is 64. Perfect. So we have a negative 4. X equals plus or minus the square root of 64 all over 2 times 4. So we have 4 plus or minus 8 all over 8. We want to get our two answers, so we're going to split it now. 4 plus 8 over 8, and we have 4 minus 8 over 8. The first one gives us 12/8, which simplifies. Yellow is a bad choice, so we'll change that. Just trying to use a different color here. So we get 12/8, simplifies by 4 into 3 over 2. Then our other one, we end up getting negative 4 over 8, which simplifies to negative 1/2. And there's our two answers. Last one, starting in our quadratic form. Then we'll look at just a few simplification problems. 2n squared minus 4n minus 7, because we have to subtract 7 from both sides. We now have equal to 0. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Check our discriminant real quick. So b is going to be negative 4 squared. We have minus 4, we have a 2, we have a negative 7. So we get 16. 4 times 2 is 8, times 7 is 56. 2 negatives gives us a positive 56. And add those together, we get 72. So we do have two real roots, we get to continue this problem. We end up getting a negative 4 plus or minus the square root of 72 all over 2 times 2. We get 4 plus or minus the square root of 72 all over 4. We now get the task of simplifying this square root, so we need to look for perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, that go into 72. 64 does not, 49 does not. We want to start with the biggest possible number. 36 does. 36 goes into 72 2 times. So we get 4 plus or minus the square root of 36 times 2 all over 4. We take the square root of the 36, and we get 4 plus or minus 6 with the square root of 2 all over 4. These three numbers all share a 2 in common. So the final answer is 2 plus or minus 3 square root of 2 all over 2. So we're just going to try one answer. X is equal to 15 plus or minus the square root of 164 all over 9. Let's see if there's anything we can do with this. We're going to look for perfect squares. Whoops. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. I'm guessing after that they don't work. So 121, 100. 81 times 2 would give us 182. That was close, not it. Pretty sure 64 doesn't go in there. 164 divided by 64. We're just going to double check. Yep, didn't think so. So 164 divided by 49. Nope. 164 divided by 36. Nope. 164 divided by 25. Of course not. 164 divided by 16. Nope. 164 divided by 9. Nope. 164 hopefully by 4. If not, then this thing is not simplifiable. Oh, there we go. So the largest one that we can actually use is 4. We get 15 plus or minus the square root of 4 times 41 all over 9. So we get, for our answer, 15 plus or minus 2 square root of 41 all over 9. We check to see if these three numbers have anything in common. They don't. So our answer is this whole thing.